people will start to join. I've also shared the link again in the messages. I don't know why it forces you to get permission. That's so strange. Definitely not ideal the way that is set up. Okay, all right. So let's see. And hopefully Adrian will be able to join. Those all just be accepting. Accept all. So today what I wanted to do is just go over a few of the basics and for moments, and then hopefully we can let's see, can I pin? Yeah. And then hopefully you'll be in a situation where uh, you'll be able to solve moments, right? Because after today, I'll be posting a recording of the major part of the lecture, and you'll be able to watch that. So what I want, because I'm at the convocation, so I'm unable to create a live current session. So what I'm going to do is go over some basics for moments, which is going to be key in helping you move forward. Let's see. And then I want to give you guys some tips for I want to give you guys some tips. Okay, so hopefully you can see my slides. Okay, hold on. Admit. Good. Perfect. So the basic thing that I want to get into is the moments. So one of the theorems that applies here is Ragnon's theorem that says that the moment of the force is equal to the algebraic sum of all the moments of the forces or the components of the forces with respect to that point. So for example, if you've got this force acting in this line, in this sense or line of direction, you multiply that by the perpendicular distance, and that will give you the moment. Now, if you were to look at this from a different point of view, you can also consider the two components of this force, Fy and Fx. And in this case, the reason why I bring that up is you can actually state that the moment of the force around A is going to be a little bit different. Now, so when you're dealing with the components, you can then act like F doesn't exist anymore, and that you're only working on with Fy and Fx almost as if they are two independent forces. That they are not the components of the same force. And what you can then do is you will then basically, here, let me, it's not muted. You can then basically add, so Fy times times dx, and it's going in a clockwise direction, so it's going to be negative. And this is important. I need to point this out, and I'm gonna take a moment here to do that. So in this case, you're trying to calculate the moment around A. The distance is dx, and your force that you're using to calculate the moment is Fy. So the moment around A due to Fy is Fy times dx. Why is it that? Because it's the magnitude of the force multiplied by the perpendicular distance to A. But remember, the moment in this case, it's going to be clockwise around A. So what does that mean? That means that this has to be negative. Remember, clockwise, the moment is always considered negative. Counterclockwise, positive. This is really important because even in the test, I noticed that's where a lot of the mistakes that I saw were happening. So then if you consider for this same setup, you've got Fx in this direction, component of the force Fx, and what is the perpendicular distance? Well, you can calculate it this way, or you just continue this line all the way through and then calculate the perpendicular distance or determine the perpendicular distance. So the moment of the force due to around A due to Fx is going to be Fx times dy. But because of the way it's set up, it's going to be counterclockwise, so it remains positive. And what we get from that theorem that we were looking at is that the sum of the moments around A are going to be equal to dx times Fy, and that's a negative that we just calculated, plus dy times Fx. And I think that right now might not be making as much sense, but when we start calculating using this theorem, it should make a little more sense to you. So let's go back to sharing. Hopefully everybody who would want to be in this is in here. So let's take a look at this. A wind is 200 pounds. So that's the force that the wind is creating. It acts at an angle from the horizontal and is applied at joint A on a roof truss. Determine the moment due to the force F around the supports at B, C, and crown D. So you're going to use the principle that we just discussed, the principle of moments, in determining the moments around these. So here's the force, and it's at an angle. 2,000 pounds, it's at an angle of 50. Right? The first thing you do is get the vertical and horizontal components of this force. So this force, 2,000 pounds, using the angle 50, can become well, I'm make sure nobody's waiting. Okay, good. Nobody's waiting in here. Perfect. This step is basically what you've already been doing. So now you've got Fy and Fx. And this is the explanation for that. Just take a look, make sure that makes sense. It's basically F cosine 50 gives us Fx, F sine 50 gives us Fy. and it's in pounds. Now what we do is we act like these are two completely separate independent forces in our calculations. In fact, it would be wonderful if we could just make the force 2,000 pounds disappear. This is the key thing. We need to know when we're determining the force, is it clockwise or counterclockwise? Another thing is, if the force is passing through the point or the axis of rotation that you're using in your calculation, becomes zero. So the component of the forces at MA at joint A are passing through joint A, so MA is zero. Now what you would use is, you want to take a look at this. So you're calculating around around C. You have to look at the perpendicular distance to C. So for Fy, it's going to be 10 plus 10 plus 10, 30. For Fx, it's going to be, so just extend this line all the way there. It's 5 feet. The same for MB. Let's take a look at MB. What is the perpendicular distance between the line of action or line of sense of this Fy? It's 10. And it's going to be clockwise. And for Fx, it's 5. The perpendicular distance to B. And it is also clockwise. So they're both going to be negative. And that's what this is showing here. So some of the moments are on B are minus Fx times 5 minus Fy times 10. And remember, pounds is in imperial, so you can use imperial units here. And you get your moment of force. And what is the unit going to be of the moment of force? Pound feet. Okay. Same thing for C. We talked about earlier. So Fy is around C. It's counterclockwise. It's going to be positive. Right? Just think about it, how it rotates around. Just imagine how it's going to be going around. You have to consider it logically in your head. And you end up Fx, which is going to be clockwise now. So it's not going to be counterclockwise, it's going to be negative. So minus Fx times 5 plus Fy times 30. This gives you, once you run through the calculation, and this essentially is all you need to calculate. Now, another interesting concept is known as the couple or moment of a couple. It's when you've got forces that are acting in parallel. And this is really important, especially in mechanics. And they have a rotational effect on a system or on a body. And it's the moment of the couple. So let's take a look at this here. An interesting example. Think about it. We'll look at one or two example. We'll look at one example here, and then I think I solved these in the recorded video. Once we look at this example, I'd like to give you guys hints for the assignment. Assignment number 3. So if you're looking to get the moment of the force around A and B, this is how you're going to proceed. And hopefully then you'll be in position to work on the assignment. Okay, so you got this A, B, and you've got, so we'll just focus on this. That's 5,000 pounds kips. That's 14,000 pounds, 14,000 kips. That's 6,000 pounds. This distance is 3 feet. This distance is 7 feet. This distance is 6 feet. This distance is 4 feet. So now I'm going to change the colors. The moment, so it's calculating moment around A. Remember, this is A. So for the first force, 5,000 or 5,000 pounds or 5 kips multiplied by, what's the perpendicular distance? 3. Is it clockwise? I would say so, so minus. Then it's 4,000 kips times 21, 3 plus 7. Is it going to be clockwise? Yes. Again, minus 6 times 6 plus 7, 13 plus 3, 16. And if you go through the entire calculation, it's minus 15 minus 140 minus, what is 6 times 16? 96. You add them all up because they're all in minus. Minus 251 kips feet. That's the moment around A. And you can do the same thing for B. I believe that my recorded lecture, which I'll be posting for tomorrow, should have more details in it. What I would really like to do now is to get you guys started on the in-class assignment. So we still have about half an hour or so. So taking a look at this first question, what you need to do is find the vertical, well, I would just find this distance here, from here to here, using the information given. And from this distance to this distance, this distance to this distance, and then multiply that by the forces, and then you add all of them. Okay, so let's take a look. How are we going to do that? So for the assignment question number 1, you got 140 kilonewtons. And you're trying to find it around A. So this is A. So what is the moment of force going to be? Because it's passing through, it's going to be 140 times 0 is equal to 0. That's the first. Then what I do is I break it down. Now let's say this is A. Then what happens here is, what is this distance? 2 meters. 2 meters. We want to find this distance. We know the angle is 25 degrees, and we know this is 200 kilonewtons. So what is this distance going to be? Well, tangent of 25 degrees is equal to, no, that won't work. I'm not going to use that method. Cosine of 25 degrees is equal to adjacent, which is what we're looking for. So let's just call this x, or just say d, the distance. Adjacent over hypotenuse, which is 2. So D is going to be equal to 2 times cosine 25 degrees. And that'll give us that distance that we're looking for, distance D. So that will give us distance of 1.81 meters. So the moment due to this 200 is going to be 200 times 1.8, 1 kilonewton meters. And then you do that for all of them. So before we move on from this, I want to ask you guys to try to actually solve, because what you do is you find the moments for each one of these individually, and then you add them up. So why don't you guys solve for 160? I've shown you how it becomes 0 for 140, and you're well on your way to calculating it due to 200. So why don't you guys solve it? For some reason my camera is giving me some problems here. Just try. Let me try to help you solve that one. Just this camera a little bit. So from the information given, I can now see, you basically, this is A, so you're going to add 2 meters. You got 2 meters plus 4 meters. So this is actually, I'll erase that. This is actually 6 meters. This is still 25 degrees. So what is this distance here? And do the same. D is going to be equal to 6 times cosine 25 degrees. Should be 6 25 cosine times 6, 5.44 meters. So the moment due to this is going to be equal to, because this is the perpendicular distance, 5.44, 160 times 5.44, which is 870 kilonewtons meters. Let me try that again. 25 cosine times 6 times 160. It's about 870 kilonewtons. And that's what you do for the last step, and then you add all of them, and you should get the answer that way. let's take a look. Is that clear to you guys? Will you be able to solve question number 1? Because if you don't understand these things, now is the time to work on them. Um, make sure that you're grasping them. Okay, let's take a look at the next question. Hope I'll be able to get through all of these. Thank you, Samira Sueta. So in this case, it's basically very similar to what we were looking at earlier in the example. So basically what you're going to do here is to get the moments around A, 500 times 2, but is it positive or negative? It's clockwise, so it's negative. 2,000 times 5, negative y, it's clockwise, right? 800 times whatever this is going to be, 4 plus 3 plus 2. And you can do it in reverse for B. 500 times 3 plus 4, so it's 1, 3, 7, 10. So it's 500 times 10, and it is counterclockwise. It'll stay positive. Would you like me to calculate at least 1 or 2 of these for you? Or do you think you're comfortable with this one? Okay. All right. Since you guys don't want to answer, let me answer for you. I'm not comfortable with you guys. So I'm going to share. See this? This is the solution. So what we talked about earlier. So let's take a look at the next one. So the moment around A is going to be what? 500 times 2, and it's minus. 2,000 times 5, and it's minus. 800 times 9. Okay. And let's take a look at the next question. So in this case, what you're going to do is it's a little bit more confusing. You got T, which is given in this direction, given the slope. You got the T, the components vertical and horizontal. You got this distance here, right? And you got another force, 300K. So these are the forces we're dealing with. And you can use the tangent formula to determine this angle here. So using that tangent formula, first determine a TV and TH, and then act like you've got 3 separate forces. The question is, what is the question? Calculating T using the information given. So the T horizontal is calculated as 13.84. And then you've got the T vertical calculated, it's 9.6. So calculate the moments due to the three different forces. And you'll end up with an equation where 300 times, so 300 times 34 is equal to TV times 25. Remember, this is minus because 300 is in a clockwise direction around A. TV times 25 is positive. TH times 15 is positive. And the sum of all of these should be 0. So what you end up with is an equation where you add all of the I'll add all the moments around A. So the first one is 300K times 34, but it's in the clockwise, it's negative, plus, so moments around A is equal to, plus TH, which we calculated, so this is going to be equal to, because they're all equal, this is going to be equal to the moment due to TH plus the moment due to TV, which is equal to 13.846 plus 9.615. You know what? I'm gonna start this from scratch because this is confusing. I don't want to use the solution. I'm gonna start this from scratch. I want to solve this for you guys from scratch. A little bit confusing. And then we'll just leave it for now. And then maybe if the other video I'll have to check doesn't have me helping you guys solve it, then we're going to have to determine. I'll have to create another video for that. Okay. All right. So remember what we did is, so we've got T, it's at a slope. So this is not to scale 12 to 5. T horizontal, T vertical. Right? And what we're trying to do is determine what T is based on this information given. So let's see if we use theta here. Or maybe we use theta over here. So this would make this 5, this 12, this would be 5. So what that means is tangent of theta is equal to 5 over 12. So theta will be equal to 22.62 degrees. Okay. So let's now erase that and construct that again. 22.6 degrees. It's T. TH and TB. This is 22.62 degrees. So TV is equal to T times sine 22.62 degrees, and TH is equal to T times cosine 22.62. What does that give us? 22.62 sine. It's 0.38. Just say it's 0.3846 T. Cosine 22.62 cosine times, so that's 0.923 T. Okay. Let me see if I can post a better solution for you guys. Assignment 3. Assignment 3. Maybe I have it here. Yeah, it looks like the solutions want us to use the ratios to determine TH and TV. So that's what we'll probably end up doing instead, because this is getting a little bit out of hand in terms of being complicated. And so the ratio that I want you to use in this case is to get TH is using this ratio, 12, 5. Remember, what is this going to be if this is 12 and 5? This going to be the square root of 12 square plus 5 square. What does that give us? 144 plus 25 square root, which is equal to 13. So this is 13. Right? So basically what we do is, in order to determine TH, we're going to use ratios. So it's going to be, TH is going to be 12 by 13 multiplied by 15. And TV is going to be equal to 5 by 13 multiplied by 15. So that's how I would determine this using the ratios. So what does this become? Equal to minus 13.846. This becomes 9.615. So use this in your calculations. If you don't, and we try to go down the other route, it seems to become a little bit of a mess. So what you're going to do is TV, what we just calculated here, you're going to multiply that by 25. You plug it in. So this is going to be, so TH is equal to, multiply by T, multiply by that by T, add all of them, and that will give you the value for T. So the equation that you should get the equation that you should get will look something like this. Hopefully that'll help you get that on your way to solving that. So on the one side, you're going to have 300K times 34, and it's going to be negative, right? Remember, this is the sum of the moments around A. And then you've got TV going to be counterclockwise, so it's going to be 9.615 T minus for TH minus 13.846 T. These would be plus, this would be minus. I think I'm saying it backwards. And this is going to be equal to 0. So 300K times 34 is equal to 9.615 plus 13.84 is equal to 23.455. So T is going to be equal to 300K times 34 is equal to 10,200 over 23.461, okay, which is equal to 3.461. So this is the answer for number 3, 434.746. Okay, so that should be your answer. Remember, this is MA, but MA is equal to 0. Let's take a look at one more before we finish. So for question number 4, if you're calculating the moment around A and B, let's see, how many weights do you have here? You've got 0.720K, that's right here, 10K, and 6K. Okay. How do they determine that? Well, some of that is because of the Planck, some of that is the density. But just remember, in your solution, just focus on 3 forces. It gets confusing if you don't. So for the first one, 0.72K around A, moment around A, remember we're going to calculate the moment around A, multiply it by, what is it? This distance is 8 all the way to here, and it's actually 9 because this is the distance we're looking at. So it's going to be, and it's going to be clockwise. So it's minus 0.72 times 9. It's the same for number 10, 10 times 13, 10K times 13, again it's minus, and 6K, this distance is 2, this total distance is 18, oh, it's already given 8 plus 8, 16. So it's going to be 6 times 16. All right, so this question is a lot simpler. And you do the same for B. In the case of B, 0.72K is 9 feet away. 10K is 5 feet away. Yeah, so you got to take a look at this, right? The total distance is 18. This distance is 13, so the difference is 5. Are you clear on these? Are you guys going to be able to complete at least these 4? The other two, again, all you do is you ignore, in this case, number 5, you've got 10K. So what you're going to do is you're going to assume that 10K doesn't exist now that you've got the vertical and horizontal components calculated. And so that would make 1, 2, 3, 4, 5 forces is all you're doing. Okay, so here's the solution here to help you. In this case, you're looking for the moments around A, B, and C. So in the case of A, how many forces are you going to consider? Just 3. No, hold on. Not 3, it's just 2. It's 205. So around A, it's going to be 200 times 2, and it's in a negative. Around A for 5, it's 500 times 1. So you can see that's how that's been solved here. And do the same for MC and B. And you can then find the resultant moment. You add all 3 of them. Okay. All right, so this might make more sense after you watch the entire 3-hour lecture. And when is it due? Or the extended version of the lecture. When is this due? It is due on the 22nd. So you got till next Wednesday. Now, officially I am off as of Monday, but if you're having problems with this, set up a session with me. Okay, we'll work through it. I will post a longer lecture tomorrow, and maybe that will help you. But we're just starting the basics. The new professor will be going over this with you for sure when he starts with you. It's starting next Thursday. Okay. All right. Just pay close attention to what he wants and what his requirements are. All right. So, any final questions for me before we head off? Uh, I think you should be okay with the hints I've given you. but I think you're gonna need some time to work through this with the new professor as well. All right. So if there's nothing else from you, you guys are free to leave. Just remember to get that assignment in by the 22nd. And yes, I am still at the college on Monday. Those of you who wanted to visit, we can go through this or anything else. I'll be there most of the day on Monday if you want to, especially the afternoon if you want to go through anything. All right. But do try to work on these solutions. Use this recording to help you. I know it was confusing. I was a little bit confused a few times, but just remember, it should not. It looks way worse than it actually is. It should be a lot easier. Okay, guys. If you don't have any questions, you're free to go. Take care, Samira.